For more than 3 decades, the Hubble Space Telescope has remained one of humanity's most powerful eyes on the universe, quietly orbiting Earth hundreds of kilometers above the surface. From that vantage point above the atmosphere, it has transformed not only what we know about distant galaxies, but also how we understand our own solar system. When it was launched in 1990, expectations were ambitious but still limited by imagination. Scientists hoped it would sharpen our view of the deep cosmos, capturing distant galaxies, glowing nebulae, and the faint light of the early universe. What they did not fully anticipate was how profoundly it would also reshape our understanding of nearby worlds. Over time, Hubble proved that its value was not restricted to the distant edges of space. In fact, some of its most revealing discoveries came from objects much closer to home. Planets, moons, asteroids, and comets within our own solar system began to appear in unprecedented detail, not as static points of light, but as dynamic worlds with changing surfaces, active atmospheres, and ongoing physical processes. Many of these bodies remain difficult to study with visiting spacecraft alone. Space missions require years of planning, vast budgets, and often provide only brief encounters. Hubble, by contrast, offers continuity. It observes the same targets again and again over decades, capturing changes that unfold slowly across time. This long-term perspective has become one of its greatest strengths. Subtle seasonal shifts, atmospheric variations, and unexpected events have all been recorded in a way no single mission could achieve. Yet even Hubble has its limits. One of the simplest examples is our own moon. Despite being Earth's closest neighbor, its apparent size in the sky is too large for Hubble's narrow field of view to capture in a single frame. Instead, it can only image smaller regions at extremely high resolution. For full lunar mapping, dedicated spacecraft are still required. Even so, Hubble has contributed in creative ways, demonstrating that innovation can sometimes overcome physical constraints. One remarkable example came during observations involving planetary alignments, when astronomers used indirect techniques to study how sunlight interacts with planetary atmospheres. In one experiment, light passing through a planetary atmosphere was reflected off another celestial body and then analyzed upon return. This approach allowed scientists to study atmospheric composition from a distance, including the detection of gases and scattering patterns that revealed the structure of distant skies. Such methods would later become foundational in the study of exoplanets, where direct sampling is impossible and scientists must rely entirely on light itself as a messenger. Within our solar system, Mars has been one of Hubble's most productive targets. From Earth orbit, the telescope can capture the full disk of the planet, tracking its seasonal transformations with remarkable clarity. Over the years, it has observed the growth and retreat of polar ice caps, shifting weather patterns, and massive dust storms that sometimes engulf the entire planet. One particularly intense global storm, observed in the early 2000s, temporarily obscured nearly all surface features, turning Mars into a swirling orange haze. These observations are not just visually striking, they are essential for understanding Martian climate cycles and preparing for future exploration, both robotic and human. Hubble has also turned its attention to the Martian moons, especially Phobos, a small and irregular body orbiting extremely close to the planet. Phobos completes an orbit in just over 7 hours, making it one of the fastest orbiting moons in the solar system. This proximity comes at a cost. Tidal forces from Mars are slowly pulling it inward. Over long timescales, Phobos may either crash into the planet or break apart, forming a temporary ring system. This slow and inevitable transformation is a reminder that even seemingly stable celestial systems are constantly evolving. Beyond Mars lies the asteroid belt, a vast region filled with rocky remnants from the early solar system. Hubble's observations have revealed that these objects are far more diverse than once believed. Some behave unexpectedly, developing tails like comets despite being classified as asteroids. In certain cases, this behavior is caused by rotational acceleration. Uneven heating from sunlight can alter an asteroid's spin over time, eventually causing it to shed material into space. This process suggests that many asteroids are not solid monoliths but loosely bound collections of debris held together by weak gravity. Other observations have captured the aftermath of violent collisions. In one case, a structure initially mistaken for a comet was revealed to be the debris field of an asteroid impact. The expanding cloud of fragments formed unusual geometric patterns, offering rare direct evidence of how frequently collisions still shape the solar system. These events, though less dramatic than planetary impacts, play a crucial role in the continuous evolution of small bodies. Farther outward, Jupiter dominates the landscape as the largest planet in the solar system. Its immense gravity influences the motion of countless objects, acting both as a sculptor and a gatekeeper. Some scientists even describe it as a partial protective shield, deflecting or capturing objects that might otherwise travel inward. Hubble has recorded some of the most dramatic events ever observed in this region, including the famous impact of a fragmented comet in the 1990s. Over several days, multiple pieces collided with Jupiter's atmosphere, releasing explosions of staggering energy. The resulting scars in the atmosphere were larger than Earth itself, a striking reminder of the violent dynamics still active in our cosmic neighborhood. Jupiter's auroras have also been studied in great detail. Unlike Earth's relatively familiar northern and southern lights, Jupiter's auroras are vast, powerful, and driven by multiple energy sources. They are influenced not only by the solar wind but also by charged particles trapped within the planet's immense magnetic field. These glowing regions near the poles are hundreds of times more energetic than anything seen on Earth, revealing the extreme nature of Jupiter's environment. Among its moons, Europa stands out as one of the most intriguing worlds. Beneath its thick icy crust lies a global subsurface ocean that may contain more water than all of Earth's oceans combined. Hubble has detected faint plumes of water vapor erupting from fractures in the ice, suggesting that material from the ocean beneath may occasionally reach the surface. If confirmed, this would open a direct pathway for studying an alien ocean without needing to drill through kilometers of ice. Spectral data has also indicated the presence of salts such as sodium chloride, hinting that Europa's ocean may share chemical similarities with Earth's seas, raising profound questions about habitability. Beyond Jupiter, Saturn continues to reveal atmospheric changes and massive storm systems that evolve over time. Its rings, while visually stable, are also dynamic structures shaped by gravitational interactions with moons embedded within them. Even farther out, Uranus and Neptune remain mysterious, their distant atmospheres studied primarily through telescopic observation since only a single spacecraft has ever visited them directly. Hubble has contributed to refining our understanding of their seasonal cycles and atmospheric behavior, providing continuity across decades of observation. In the outer reaches of the solar system, even small discoveries carry significance. Hubble has helped identify faint moons and irregular objects orbiting distant planets, each one a fragment of history preserved in cold darkness. These findings reveal that the outer solar system is not empty or static, but a complex and evolving environment shaped by collisions, gravity, and time. After more than 3 decades of continuous operation, the Hubble Space Telescope has exceeded every expectation placed upon it. It has bridged the gap between planetary science and cosmology, between nearby exploration and distant observation. Even as newer instruments extend human vision further into the universe, Hubble remains essential, offering clarity, context, and continuity. Together with next-generation observatories, it forms part of a growing network of tools that allow humanity to explore both the vastness of space and the subtle complexity of nearby worlds. And despite all that has been discovered, the most important realization remains unchanged. The universe is not a static backdrop. It is active, evolving, and filled with processes still unfolding. Every observation hints at deeper layers of complexity waiting just beyond current understanding. The more we see, the more clearly we understand how much still remains unseen.